Good afternoon. Thanks for joining this session. So when you guys deploy applications today, deploy your services, how do you work with the people that provide you your virtual machines? Do you have problems like they give you a long Microsoft Word document that you have to fill in and you have to provide details about every VM that you're going to need and what software you want on it? Perhaps in the course of trying to get the provisioning across the different sites, you have to go back and forth and you have email threads that take a while. You may have lots of phone tag, meetings that don't actually seem to give you what you want. And perhaps they give you back a list of machine names that you have to go cook into config files, thus figuring out now how do I start conveying the config files back to whoever's going to set up the VMs. And all of this takes time figuring out. And then you find a bug. And then there's a change order. You're suffering some pain there. Sigh. Takes hours of turnaround time to get it done so that you can attempt to do some deploy again. You think, I'll just SSH in, assuming that you're not in prod and they've given you that access, and I will fix the problem. Meaning full well that you're going to go fix your scripting somewhere that deals with whatever it is that you discovered was wrong in the deployment. But somebody interrupts you, you don't get around to fixing it, and then the bug shows back up again on their next long, protracted deployment. Good news, too many people using your stuff. You have to scale out. You have to reset all the way back to the beginning with the guys that are giving you your VMs to be able to scale pieces of whatever the various clusters that you're using out. Somebody says, hey, we've got to have this thing in the East Coast data center and the West Coast data center because we need greater availability and business continuity. Those are the questions that we're going to talk about in this session. My name is Bill Keenan. I work for VMware. I arrived in Silicon Valley in '84. After doing some startup work, I went to work for Apple Computer as the technical lead for the file systems project. Spent about 5 years there before going to Sun Microsystems, then JavaSoft, where I worked on what we now call Java Micro Edition. Along with Bruce Delagi and John Bozak and Bill Smith, we did the original work on what we now call Java Web Services. And with Dave Patterson, Barry Medoff, and Jim Peek, I also wrote a paper called Redundant Array of Inexpensive Memory, which is about taking computers and making memory become the system of record for your data, and disk being the backing store. After a little group architect work for Intuit, I then arrived at VMware. Yes, sir. I can't hear you.
I'm sorry, has the system changed? Is it not covering Gymfire anymore?
Gymfire is the technology base that we're using to talk about all of this. It's what the bits that we had available to us that we've tried to use throughout different customer experiences. And with that, I'll ask Manny to introduce himself, and then Mohit, my other co-presenter.
Hi, I'm Manny David. I've been with VMware for a little over a year and a half, but I was a prior employee of Gemstone. I've been consulting for their GemFire distributed caching technology. Prior to that, I was consulting using coherence technology. So I've had several years of experience with distributed caching. I'm currently implementing GemFire topologies throughout multiple client bases. So that's my focus, and we are using GemFire as the case study for this app director deployment. So with that, I'll introduce Mohit.
I got this figured out. All right, my name is Mohit Vaswani. I'm the product specialist for the application management suite, so products like Application Director and APM. Been at VMware for about now 4.5 years, so apparently that's a really long time at VMware, but it's been a great ride so far. Question already? You have a question? Okay, good. That was pretty quick here. So I won't take too long introductions. We have a lot of stuff to cover today. Just a quick question for you guys. How many were in the App Director presentation this morning at 8:30? All right, good. So you guys, we've talked about App Director a little bit. If you guys have any questions on that, but our focus is going to be how we can actually work with App Director and GemFire together. So I'm going to hand it over to Bill to start off with, and then we'll break through.
I have going on here. When you end up with a distributed, any kind of a distributed system, a set of clusters, and GemFire is certainly such a system, then what you want in terms of deployment is something kind of like we've come accustomed to having in Spring. I would like things to auto-wire together. I'd like to be able to use context, and or perhaps we might call that profile. I'd love to see the boilerplate kind of stuff just sediment into the system and not have to do that so often. There's quite a lot of configuration cumberness, if that's a word, cumberness, in such subsystems, be those GemFire or other equivalent cluster things, or your own clusters that you might build out of application servers. In order to allow behaviors like bootstrapping A and B or A, B, and C, we'd love to have a semantic that would let us create dependencies on a future that we would block until the value of the future was set and then continue execution rather than having to code or to put in particular logic in our deployments or installation to make that happen for us and then have to refactor every time we want to change that semantic. And I'd probably like to have some interesting events that I could act upon, such as scale out and do something different, like in the case of clustering of a GemFire. Scale out means I've added more capacity, and so I want to redistribute the data across the larger cluster. As we've kind of talked through some of the questions, in this presentation and all this demonstration, we're going to use technologies that we had available because it was relevant to customers that we've been working with. But just so that you understand, for anyone who doesn't know what GemFire is, it's an in-memory data grid. A typical site is built out of looking at the audience's right and going over to the left. There's locators. That's a pretty common paradigm in databases, that the locators then know about their cache nodes or their database nodes. The locator takes care of high availability within that cluster for failover and understands things like if the data is to be partitioned, where it will be found. The cache nodes themselves are holding whatever subset of the data they're supposed to have. We add a rebalancer that Manny will be talking through what that service does for us. And then, because in this particular case the problem we were trying to solve was for multi-site, then we added a WAN gateway that would take care of synchronization of data. In the context of all of this, we would like to have as much of the deployment be dynamic and bound at deployment time and not be baked into configuration files. To do that, we had to think different about some tools that we had and look forward to some things that we will hopefully sediment again as boilerplate becomes more certain of what the right shape and the way to do things are. We will attempt to sediment into the infrastructure the ability to do lots of things. But today we had to build wrappers and things that, again, Manny will be talking about shortly. So with that, I just wanted to say that was the raw technology. For those of you that already know GemFire, you know it well. If you don't know GemFire, you don't need to understand the technology per se to follow at least the problem space that I have of deploying distributed systems. For those of you that have other systems that you need to deploy, maybe LDAP systems or Redis or other kind of data stores or your own custom-built things around application directories and notions that you need to The first things that we're going to be talking about should all be applicable to any of these clustered deployment problems. Right now I'm going to ask Mohit to talk us through a bit about what Application Director is, a tool that we're using and then extending by some technologies that Manny wrote for us.
Thanks, Bill. So when I speak to customers in the field, we usually see, like, even our own IT, like, it takes a long time to go provision applications, right? And in this case, we're talking about GemFire here, but in general, getting a VM, getting your application servers, databases, everything all connected, and then you need to go say, I get a request from a the development group, I need this application provisioned. It's a whole long process, and as Bill mentioned, you get these documents you need to fill up, how much memory, etc. So it's a long process that goes anywhere from 4 days to 8 weeks, right? And that's how traditional app provisioning works today. But what we really want to do is get to a point where we can get this down to minutes. What we're going to show you today is, we built this what so-called architecture or blueprint of GemFire. We actually initially got it done to about 15 minutes. Is that right, Manny? All right, so we actually deployed it this morning. We'll actually show you a live deployment of this entire cluster that Bill showed in the previous slide, and we brought it down to about 15 minutes of deploying these VMs, deploying all the GemFire bits on there and connecting all the dots together. So that's what our goal is with products like Application Director. And those of you who were there in this morning's presentation, the whole idea is that it's a very model-driven approach, right? You want to build what we call is a so-called blueprint. It's essentially the architecture of your application, right? What are the different components? Can I put a web server there, my application server, my messaging, my database, and how are these connected? So if you think about it, when you have an application, you have different roles in that application, right? You have an architect who knows how to connect all the different dots. How does my application server with my web server, with my database, etc., right? Then you have certain guys who are built and who know the application server inside out. What are the certain properties I need to change to tune my application server, right? Which port should it run, what database, etc. So these architects, these what in the application director term, what we call is the catalog user, who are building services for your applications. Services are essentially that software that runs on your so-called VM. Now, once you all connect these dots, you put my OS, you put all the servers in there, and say, I need to run my TC server before my application, my web server, and then when the TC server comes up, send the IP addresses to my web server so I can load balance all the application servers together. What I really need to do now is be able to deploy this in an infrastructure. So your infrastructure layer should be kind of abstract to you. So I get a request, say, for my dev, and they deploy their application to their so-called infrastructure in the cloud. They may want to change certain properties for that specific infrastructure. I might have a different database, username, password, different port. But for my production, I may have a completely different property. I need more CPU, more memory. So the idea is to standardize on your blueprint so that you can use the same blueprint across various different profiles. And these profiles, for example, could be dev, test, production, could be deploying to your public cloud, private cloud, or even things like EC2, right? You're not changing the underlying blueprint, but you're actually going and saying, I can go deploy this across various different profiles. So once you have this whole concept set up where you build services blueprint, now you can actually deploy this across various cloud, that is great. That's day one, right? You've done a great deployment, what's going to happen again. We create releases every now and then, right? Every week. This is all agile program. You guys are pretty familiar with it. So the idea is now, once I deploy an application, I need to go now update code. What do? I need to make changes to certain configuration files, right? So we need a way so that we can have a more model-driven application management process. I may want to do things like, which we'll show you later on today, is scaling out. So looking at true real-time metrics and seeing, okay, what happens if my application is running slow? I have high usage, right? What am I going to do? Can I go ahead and scale out? I have too many hits on my specific application server. If that's the case, I need to have the ability to scale out my application server. And what does that mean by scaling out, right? When I'm adding additional VM, I need to install the bits again. I need to go ahead and install, the WAR file. But I also need to make sure that all the dependencies that are affected will need to be changed. So if I have a load balance, I need to go configure my load balancer with this new IP address, right? So essentially, any change that you make, any update, when we talk about from the app director terms, update code is just is a type of change. You may want to change certain ports. You may want to change, the URL. You may want a different release, for example, right? You may want to change the URL point to a different repository. So once you make this change, you update the profile. You can then go make that change across various different profiles. So once you go say, I have my dev profile or my QA profile, I'm going to go deploy the change in that profile. Let me go run some tests, make sure everything is up and running, and then if it's up and tested, you can actually then propagate that change now over to your production profile, right? Because you haven't changed the blueprint. You have two deployments set up. You have new code. You made the change in your QA profile. It's up and running. Good. Now I can propagate the same change across my production profile. So what we try to do is we're going to actually show you in this session now, and we're not going to do too many more slides. We have a few slides that talk about how we set up our GemFire code and mostly talking about a demo, but how we look into App Director, how we build this blueprint. I will get into talking about the services. What are services? We need to understand that services are essentially like things like I build a service for Apache. What are the properties that I need to expose to the end user for this Apache property? That can be changed for a profile. I need to change the port. I may want to change how I install it, etc. So we'll get more into detail about services, and once we get into App Director, the UI, we'll actually talk more about the blueprints.
So, Mohit, why don't you count the, oops, Manny, where'd your, there we go. Oops. Boy, very touchy touchpad.
Yeah, too many cooks in the kitchen right now.
We built, you saw the one screenshot, but what I want to do is get to so let's count clicks here to get, this is deploying about, about 14 VMs, I think. Okay, and there's one click to go into deployment. Everything's already configured. We'll walk you through and explain other things later. We just want to get one going.
So what Bill is doing over there is just walking you through a deployment of the GemFire blueprint that we have, right? So the idea is we built this blueprint for you, and we're doing something called a quick deploy. Essentially, we're just going and saying, okay, here's the version of this blueprint, and I'm going to go ahead and deploy. And we'll actually talk more about the whole blueprint in a bit, but we want to go ahead and start the deployment because it takes about, as I said, 15 minutes. I don't want you guys to sit over here 15 minutes and watch the screen go round and round. But once we go ahead and set up the deployment, we'll actually walk through and go back into the blueprint and see how that's all set up.
Thanks. So I just did the long way and the short way, deploying to two data centers, one in the east, one in the west, the same topology, and then through technologies and wrappers that Manny's about to describe, they're going to find each other and then set themselves up as a wide area network synchronized East Coast, West Coast data center instance that we can then load balance content between and populate it and have redundancy and failover or active technologies coming in and connecting, and Manny will be able to speak to all of that. But in this case, it was less than 10 clicks, and we've got 14 VMs spinning up to create two clusters. Back to you, Manuel.
So I've had the pleasure of building these components that we're using as services for used by App Director. So I'll go over the components that I built and what it took to build them, actually. Let's see. So here I just list out all the different components I could identify. Now, the main crux of GemFire is configuration. Now, usually in a standard installation at a client site, without virtualization, we have to provision everything manually. So all the IP addresses, host names, port numbers, even the file systems have to be identified before we attempt any kind of deployment. If you can imagine, we have multiple environments. We go from development to integration to QA to staging to production. These could get unwieldy, as Bill has described. So what we've attempted to do here is show you how we can standardize the configuration using some tools that exist today to simplify the deployment process. So these components I built were built for that purpose. So we have configuration, and then a metadata server really is basically what you'd use a DNS for, a domain name server. It provides appropriate IP addresses and port numbers and attributes of deployment we're interested in. We'll go over that a bit. Locator is something that all the cache servers and the gateway should be aware of, because the locators actually maintain the view of the entire cluster. They keep track of additions and deletions of members. Cache server, obviously, it's where the data lives. Gateways are specific forms of cache servers. They actually, their purpose is to move data from one place into another. They are also cache servers, but all they do is they're just proxies. To demonstrate this application, I created a data runner. Basically, just as you can imagine, it just creates data and publishes it out. Rebalancer is an important component of a scale-out solution. So in real time, if you were to add additional VMs to the cluster, GemFire does not automatically rebalance data, because that we propose is a expensive task. If you can imagine, every time you spin up a VM, if you rebalance on every spin up, you'll be moving data around from one VM into another. That's a lot of serialization back and forth, and also affects the system usage. So in order to build out the configuration aspects of this deployment, I needed to glue together different technologies. Mainly Spring for property placeholder and bean creation, and the new Spring data-gem-gs that's been released, or I believe we're at 1.2 now. The version I used was 1.12, so there's a lot of features that were missing, which I needed to implement through brute force using Spring and Java. Server config is something I encapsulated the notion of a configuration. So anytime you deploy GemFire, you need certain attributes always, right? These attributes change from environment to environment, like file system location, IP addresses, any number of things, which I'll show you in a bit. They rely, also, it makes use of Java.io file. So GemFire is a shared nothing architecture. So what that means is anywhere you deploy it, you expect that you will have some type of resource available to you and expect no sharing among different resources. So what I've attempted to do is automate the process of resource allocation and provisioning. It's real simple. I'll show you in a bit. Config properties is really just a properties file which I'm tricking GemFire into using in order to start GemFire in its own using its own mechanism. So what I've done with that is integrated Spring technology with GemFire, which GemFire is not Spring aware, so we needed to glue together some components to make it usable. This is the topology we're trying to deploy using App Director. We've got 2 sites. Just know that we have replication happening. Those purple lines indicate direction of data. So this is a bidirectional flow of data from one side to the other and back. Let's see. Cache servers are in there. They're called site members. This is an old diagram, so apologize for that. I wanted to show you some examples of, the sequence flow for a locator, for instance. So a locator is wrapped by a launcher, registers itself to using the metadata client, which actually talks to the metadata GemFire server to register itself, and afterwards it waits for other locators to register themselves. Once all are present through a quorum attribute, the locator will start. And real simple. It's just a simple main class. Launch so I developed this component called metadata client. It encapsulates the behavior of client connectivity to GemFire using Spring technology. So let's look at that configuration. Any questions out there? Please feel free to interrupt. So now it's looking like Spring. We have all these context files. The locator is associated with a context locator. Let's see. Like I said earlier, I used a lot of gluing here to integrate GemFire with Spring and actually Spring Gemfire. So the server config class I talked about, these are the attributes I'm interested in. Base directory, the system name, site name, bind address is really a locator or, a host or a IP address. Server config hooked up with a config properties class will actually bootstrap GemFire correctly when it starts up. All the other pieces, if you've been playing around with Spring Gemfire, actually the locator is a special server in that it doesn't have a cache. So this is probably not as interesting as far as looking at what a cache server looks like. So let's go on with, so we have locator. Cache server is similar in that all it does is starts up and wait for locators to register themselves. Once they're registered, it starts up. A gateway is special in that it needs locators as well as it needs to register itself. GemFire's pre-7.0 does not have any means of discovery of gateway endpoints. So we have to do this the hard way and actually register manually. In GemFire 7, on the other hand, we have a new feature of auto discovery for gateway endpoints. The gateway itself will wait for endpoints from the other perspective, from the opposite end. So we tell it how many endpoints to expect and where to connect to. So actually, this is a typo. This is not get locators. It's actually get endpoints. And once it receives all of its gateway endpoints, it'll start. Data runner is a simple Spring Gemfire client, which we'll go over in a bit. And Rebalancer. Rebalancer is a special Gymfire client. So Bill talked about timing when we're deploying VMs. You cannot, with Gymfire, you expect certain events to happen before a gateway starts up. For one thing, you need to make sure there's locators. Gateways expect gateways on the opposite end to be alive or at least be present or known about. I'm sorry, I'm switching context here. Sorry, we're in Rebalancer. Rebalancer expects that cache servers are up and running. So with App Director, there's a notion of executing a component, a service, but you need to listen for events such as completion of a step. For Gymfire, on the other hand, we started using regular Java runtime and no hup, so basically a bash script. So the Rebalancer code has to be more complex in that it needs to be aware of timing. It needs to be time constrained. So the Rebalancer is just a client, but there's a special function. I'm not sure if you're aware of the Gymfire features of function executions. So we developed a function, a Rebalancer function on the server side to accept this execute command here. Whoops. Sorry. Execute here basically triggers the rebalance function, and we'll go over that in a bit. Right, so now we'll go over the important components, continue that. So the Rebalancer code, like I said earlier, is just a simple client using Spring Gemfire. And here's the rebalance code. All we need to do is obtain the pool, number of servers to expect as part of this rebalance task. And then we execute it. This is an asynchronous process. So all Gymfire will do is give you a result saying, in this case, we were interested in which server this actually occurred on. The function service is a special feature of Gymfire in that it allows you to use your distributed caching platform as a grid compute platform as well. So when you say on server, you're telling Gymfire to execute a function on any servers that it knows about, and basically spin that process off and return. You could actually tell Gymfire to execute it on servers, which means execute it on every cache server if you want to do some kind of heavy-duty processing. I've used on servers before when I tried to load a multi-terabyte load from a multi-terabyte database and try to feed that into Gymfire as fast as possible. So if you have a grid a data grid of 100 nodes, and if you do on servers, so that's 100 processes. If you take each process and use multi-threading, split that up, spin that up to 10 or 20, depending on how many cores you have, that's 100 by 100. So you could imagine the grid capability of GemFire. So that's the function feature. Let's see. I'll show you the other end of this, the rebalance function. So when I executed the rebalancer, I actually passed in a property called expected servers. I'm using that. I'm using here GemFire's internal features, the distribution manager, to tell me who the members of the cluster are. It tells me who they are, but for this demo, we're actually naming the hosts, the cache server hosts, we're prefixing them with cache. So I know for a fact that any host name that begins with cache is a cache server. So as soon as I meet my expected number of cache servers, I could then execute a rebalance task. And that's all I do here. So start here is, as you could guess, it's a asynchronous process. So that tells GemFire, the entire distributed cluster, to execute a rebalance. At that state, during that process, GemFire will be active and it will accept operations from clients. So you could do any put or get operation. The only caveat is tasks are queued up. So if you're attempting to modify data that's being modified or moved from one VM into another, you'll go into a wait state. But aside from that, your process will execute quickly and then just return the result. Anything else?
Yeah, so why don't you ask a couple of questions? So Manny, if I kind of follow what you've built here, you took a system for which Spring has added a capability, Spring Gemfire, that lets you manage configuration of a complex runtime. So in the past, people would use a DTD-driven complex XML file to set up configurations and have to bake that into a deployed file system artifact. And you've popped out, and using Spring Gemfire and context files, you're able to now do all the configuration as part of a more binary distribution. So in other words, I can take a tool that would let me push your wrapper out, your launcher out, and it picks up the context file and uses APIs to do all the configuration. And that's one major piece of what the wrapper is doing. Is that a correct, or expound on that? Is that true? How's that work?
That's true. So as I mentioned earlier, GemFire is relies heavily on manual configuration. So if you were starting GemFire actually using the out-of-the-box components, we provide for you basic startup Bash and Windows startup scripts. If you take a peek in there to see what we do, we actually rely on environment variables, some attributes that we're exporting in order for GemFire to start up correctly. So what I've done is create this server configuration class and this and the config properties class. But server config is actually the crux of this. It's got all the components I need to start Gymfire. We have base directory, system name, site name, cache server base port, JMX as well, because another key feature we wanted out of this deployment was better monitoring. Gymfire provides monitoring out of the box, but the GFMon that was built for Gymfire relies on an agent, and the agent can get very bogged down depending on the number of nodes that are deployed out in the cluster. So what I attempt to do is allow the configurators and operations to group their monitoring off Gymfire and basically allow them to make them smaller, the cluster size smaller by logical groupings to allow integration from a Wiley or a OpenView or what have you. You just define JMX URLs to connect to monitor. Now, I created I'm not really presenting it here, but I created some components to support Spring JMX. So one of the purposes of going Spring was actually to be able to use Spring's bean definition features to allow us to modify the deployment as we need. So for a cache server, for instance, I deploy what I call a peer monitor, which has some operations like, well, this one just shows you the status. But I could add many things in here to add operations like a shutdown server or restart server. It even has some configuration to change the log4j during runtime, the log4j settings. So that's one aspect of the Spring framework that allows me to configure Gymfire from basically from dynamically without having to hard code anything in any property files or basically the hardware.
You know, maybe you should describe kind of some prior iterations of this before creating a Java, using kind of this concept of it, writing in Java a launcher that would take the config in a very Spring way, using a Spring API like Spring Gemfire to do a configuration of this runtime. And how else have you done that in the past in other cluster engagements? I think you were telling me something about scripting and just some of the shell problems that you had in the past. Then describe some of what it used to be like.
Right. So I mentioned earlier, Gymfire out of the box requires bash scripts and Windows scripts to start it. If we take a peek in there, it can get a bit unwieldy. Let's take a look. Look at one particular version. Actually, these are simple startup scripts, but these scripts, agent, cache server, Gymfire, they're very generic. They will run as out of the box, but they need all sorts of attributes. I'm not sure if you can see this clearly.
Nah, probably not.
No?
Yeah, it's pretty small.
Yikes. Well, anyways, they require you to pass -d arguments to the Gymfire startup scripts. So if you can imagine an operations, they fear these scripts because any little attribute will change the behavior of Gymfire. So you could pass in a wrong IP address, let's say a locator, for instance, and basically accidentally connect your cluster to a QA environment or a production environment. So that gets, there's a lot of issues around that, obviously. So what we try to do is, through the wrappers, is to standardize this and basically do it at the app director level. So, right now, if you're attempting to stand up a GemFire cluster, you have to order the hardware, which usually takes, if not months, it could take a year. And then the actual provisioning of that hardware, installing operating systems on it, and setting, the correct operating system attributes like file handles and file system, mounting the drives on there, whether to use SAN or NAS or local hard disks. So all these really make configuration for GemFire difficult, as any other enterprise application or platform. So the scripting itself is something that we want to get away from and actually do it in some other form like, Spring Gemfire. Spring Gemfire simplifies that process for us. And I'll show you here's a rebalancer. To define a client cache for a client, this is all it took, GFE client cache attribute, define the pool, set the host binding, and the port numbers as well. You define a region. As simple as that. Just give it a name and tell it which cache to use and which pool to associate itself with. And the template class provided by Spring data-gem-gs allows you to operate on GemFire itself. So it's got all the important things that you need, like put and get operations, even some added things like replace, but important are query and find. So you have all the CRUD operations you need to work with GemFire from a client perspective. It's as simple as setting up this small context file. Now, mind you, I've not moved to the next step of using the annotations components, but that's a logical next step, but to a certain degree. I wouldn't go fully to annotations.
So by comparison to, we have a question here, but let me just.
Can you explain a little bit about the rebalancer? Is it like a service that's running all the time and they're sending rebalance requests?
Yeah, so a rebalancer needs a distributed system to connect to in order to request that a rebalance be executed. So the important component, the important arguments are a distributed system ID and the number of cache servers that I expect to be present in this cluster. And we'll show you that in a bit, right, with the rebalance. Are we going over that? Mm-hmm. Right. So it actually, rebalancer basically says when you execute it, it will actually send a function execution request to the server. The server itself will decide when to execute that rebalance task.
And but Annie, I think maybe part of the question is, in the case of GymFire, for whatever the set of cache nodes are, it's maintaining balance just naturally. It's only if I change the cardinality of the number of nodes that then I want to proactively get the data rebalanced, and then it'll just stay balanced across the nodes until I change the cardinality again. So we wanted to write a way that would change that for the runbook. And Manny, maybe you can talk a bit about how using this, building this Java wrapper to launch what was a pre-existing product into its particular modes, do all the configuration from a point where we could see it in code and kind of blending together, again, the context files in. How does that change relative to other times you've done it in shells from the perspective of delivering a runbook to ops and the ability to maybe do things in parallel that before you used to do serially for a large deployment?
Right. So if I were asking ops to do this for me, they would actually execute these manually. We have a tool that ships with GemFire. It's called GFish. It's basically GF shell. That's what it stands for. That provides some operations for us that we can execute at the cluster level. So one of the advanced features for GFish is rebalance. But that's a manual process as well, because when you execute rebalance in GFish, you have to tell it what member to execute on. This is one of the tricks that we faced in automating this task. So I don't have GFish here with my rebalance function. So I'm actually just asking GemFire to execute this rebalance. It doesn't matter anywhere, just execute it. So when I come from a rebalancer client, so this client gets started up by the app director, and here's the rebalance method. Find the locators, then initiate the connection to the GemFire cluster. I need a pool to basically feed in as a argument to the function service. Basically tell it where the grid is, and then the number of servers I'm expecting and what function I'm expecting to execute. So by the time I hit execute here, GemFire will respond back quickly and say, well, actually, I'll show you the other end of this. So this execute triggers this rebalance function execute method. So in here, aside from setting up some initial properties, I'm retrieving the number of servers I'm expecting, and member ID here is basically identifying myself in order to return the result back to the client saying, hey, I executed this. This is my name. This is the important piece here, the internal distributed system, which cache knows about. And based on that, we asked its membership manager, and give me the list of members. So the net view basically gives you that list. And in here, I'm iterating through. Now, this is a do-while loop. So in here, this is that, so I'm actually trying to ensure that all the cache servers that I expect are running when I execute this. So the problem here is if you don't do this, a rebalance will execute before your cache server comes to life, in which case your rebalance operation was unnecessary, right? So if you have 4 cache servers to start with, if you execute a rebalance, then there's no data that needs to be moved around. When you scale out, let's say you add 2 additional cache servers, you have 2 then that will not be accepting data until you execute rebalance. So in order for the rebalance to actually work, I need to make sure that those 2 cache servers are up and running and ready to accept data by the time I execute the rebalance. So that was a complex portion of this feature that looks like a simple command, but it's not so much.
Yeah, Manuel, why don't I show them a little bit of the blueprint and put some of what you've written into the context of how it solved our problem and how it might solve problems and other things that they have to deploy.
Fantastic.
Turn it on.
Question.
Yes, sir.
A couple of questions. One is, you mentioned a metadata server. I saw that the configs you're using for GemFire have essentially property limitations for GemFire, presumably being retrieved from a metadata server.
Yes. So
What's the resolution process, and where does that resolution occur? Does it occur after the config's been deployed? Does it occur at the beginning of the deployment process? So does the metadata server enter into the process, and is the metadata server a runtime dependency for the deployment?
Yep. So it is a runtime dependency. It's one of the few cross-cutting concerns that we have to sediment into this sort of deployment. So from a design of how to think about the DevOps piece of dealing with this clustered system that we knew that we wanted to deploy multiple times and interconnect them, we knew we would have some cross-cutting concerns. Our desire was to minimize those sets of concerns. Even inside a single deployment, we wanted to minimize them by not having to know a priori names of machines or IP addresses, for example, to let the cloud return those at the point that the resources were consumed. But the problem now is if there's resources that I'm going to get from the cloud dynamically and the other side needs to know those values, what do I do? How do I arbitrate that? So we built a simple, very simple metadata service deployed external. One might put it into DNS in an organization. It would just be present. The launcher actually takes responsibility for registering the few properties out of a deployment instance into the metadata service, the ones that you know that you have to coordinate around, such as the IP addresses for the locators of this cluster. So the launcher for the locators is making sure that the locators get registered, their IP addresses get registered into the metadata service. Likewise, gateways. That's the way the gateways find one another. We have to do it. Now, a clustered Gymfire has another notion of saying an instance is called a distributed system. So I can have distributed system 1, 2, 3, 4, whatever I want to call them. They can be alphabet numeric as well, East, West, Europe, Asia, something like that. So the lookup is for the distributed service, I want the locators. Okay, that's one coupling. Now, when I deploy an instance of what you see, like at this point, the distributed service is not defined. When I go to do a deployment, I will give it a name, and that becomes the distributed system value. And the locators then get registered as well as gateways. The other thing that you end up needing, and this comes to a point that I made in the questions to try to hook you in, I'd like to be able to run my deployments as fast as possible, meaning I want as much parallelism as I can get out of my infrastructure to go and spin up things. I can't control the order that things will be, therefore the order that my VMs will come up and be started for the various pieces in these complex systems. So one of the things the launcher can do is it can implement the semantic of a future. I know that there is going to be a gateway IP address for distributed system 3. I will wait until such an address becomes available, and then I will pass the address in. I will use, in this case, Spring Gemfire. I will use Spring Gemfire to configure that gateway with what its remote side is supposed to be at. Each side can be in that point. So as soon as each side comes up and we know their IP addresses, they go into the service, and then they could each be waiting to know what the other is. Well, the logic of building up their IP addresses come in, and then they can both start to resume. In the past, we've, in terms of how we build the software, it's all easy and well and good until we have to operationalize it and turn it into something that is a runbook. And the way to get these deployments to start happening, we've had to contrive our scripts to break them into segments so that we can get partial information out and cause them to connect between things, and we can orchestrate basically a serial flow. Part of what we've accomplished here is trying to sediment that kind of gross work into basically boilerplate models so that ultimately the writer of the deployment, in this case the author of what we call a blueprint, what you see before you, doesn't have to be concerned with that. Here's an example of, so on that locator, sure.
So now I see how you get the data from the metadata server and how that data gets pushed to the metadata server. You then need to communicate that data to the Gymfire runtime, something that was previously done via environment variables.
Yes.
Is it the case that you're now, the service that is starting the Gymfire process is in fact doing a shell invocation with the appropriate command line variables, or are you actually spawning a Java thread and passing in the configuration? Are you doing that via system properties, or how does the Gymfire jar know what the values of these properties are?
So right here is the invocation of the launcher for a locator. So you can tell by the last row here, I know you can't read it, but it's the locator launcher. Because Gymfire, like most servers, needs to run continuously, it's in the background. So when we go to say start it, we need the remote side to actually complete and return so that we know it did the job. Unfortunately, there can be some time for the process to actually come to life and quiesce. That was part of what we had to build into things like looking for futures and wait for things to happen, for it to actually, the runtime to actually have come up and done some quiescing. In this case, you can see that we're using application director to hold the set of properties, to hold all the configurable metadata. More and more, application director gives us the ability to auto-bind things so that we're doing less typing. Across the set of machines, names and other connections and dependencies start automatically filling in, and property values just become dependencies of one place. So I edit once, and everybody else gets to just use the value. And then we pass those arguments in as shell context. And in this case, the Java process is launched by creating a bunch of Java properties, making it natural for the Java developer to just get them. Right in the beginning, I know this is small print, but it says the context mode that we're running in comes in. There's a shell variable for context mode. That variable happens to be set to locator. Locator is going to be used to find the Spring context that has all the stuff. So now as a developer, I'm starting to build my configuration as that in a way that's very nice for Spring as context information. I'll take an API that knows how to manipulate an older, more complex runtime, such as Gymfire. And if we start to apply that pattern, we can imagine building out more systems. As we do our own Java things and we sort of bring up services, and we start building thin slice applications that compose against those services, well then services that I build start looking appealing to somebody over here that wants to build an app, and now how do they create they have a cross dependency. That's all great if everything's up and running, but how do I bootstrap myself? How do I do rolling upgrades if I have cross dependencies? How do I get this thin slice app to switch over and become dependent here? Somewhere I have to start triggering the notion of rewiring. That what we enjoy in how we build a servlet with auto wiring, we need to do across virtual machines within a cluster of services and another cluster of services and a third cluster of services and 15 different thin slice apps, and they all need to start auto wiring as we deploy. And as they scale out, yes, sure, load balancers can hide some of that from me, but sometimes I have the semantics of something like a database where I actually have partitioned regions and data. It's more complex than just simple HTTP load balancing. I've got to break that apart. And you can see that from a start operation, a configure operation, that's a very short piece of scripting. It just launches some Java code that will go do all the work. A little bit easier for a Java developer to debug, I would assert, because it's more native. They can put it all into their normal source code control system. It flows with the way they do their applications. It's less error prone for the ops guys. It stops us from wanting to go down and SSH into a machine and manipulate it to get something to happen. Instead, we just fix it back in the model and we just redeploy. Since the deployment engine is doing everything it can possibly do in parallel, then we take, in my case, we just did in about 14 minutes, we just deployed 2 complete GemFire clusters in east and west and interconnected them so that they have a pulse and they're now active. 14 minutes. I can tell you, as we were building the demo and getting it working, it was really convenient that it was that fast because we didn't get it right the first time. We had to get some things fixed as Manny was writing his code. So here on this rebalancer, that I know that was a bit fuzzy to hear it, even as I knew what was going on, it's still fuzzy to understand. These blue lines are dependencies. In the case of the blue line, this blue line right here, I have a dependency between the rebalancer and the cache nodes. So if I scale the cache nodes out, then an automatically computed concept in the model, that is the list of IP addresses for all the nodes, changes. And as a result, the model knows that the rebalancer is dependent upon that. And right down here, I know this is all this last item here, cache server IPs, it depends on all of the IP addresses for the cache servers. So as soon as I scaled out, the IP list changed. Therefore, the update logic for the rebalancer must be triggered. We used to have to write very complex shell for the ops guys to be able to cause those kinds of changes to happen to the things we would deploy. And now I just can draw a line, create a dependency, and deploy that all with the artifacts of my application or my service tier, more likely. And it can happen. Now, in what Manny was describing about the wait condition, because, again, a cache server is a daemon, it has to just be fired off into the background. By the time we're doing everything in parallel, so as soon as it returns saying, I launched it, well, yes, you put it into the background. That doesn't mean it finished initializing. We had to say, how am I going to wait? Well, we had to write some code that would say, you're expecting to go, the new number of cache nodes should be 4. It was 2, now it's 4 nodes. When you see that there are 4 nodes, that's when you can move on to actually firing the rebalance event against the newly formed cluster. And I bring that up mainly because I'll bet we have written a lot of code where there's a point at which it needs to quiesce. There is something about a system that we have put into our deployments that if we're going to start automating some of the lifecycle management of those systems, we need to find a way to write specific logic that understands what happens on its startup logic and creates waits. I'd rather not, I think most of us would rather separate the concern of understanding that from the act of describing what the scale out looks like. So such that scale out, and maybe I'll just pivot to another screen while other questions are coming in and just show what that might look like. Such that scale out is a pretty orthogonal issue for an ops person, and eventually just becomes something that we start automating rules around to say, I see that the performance is getting low. I know that my cloud has enough resources. I'm going to scale this critical resource out and reassess if the overall running of my system is in balance again, because I'm seeing something start to get up into yellow. So here's one of those that we just deployed. We did a ping and found out it's about 130 milliseconds round trip back to Palo Alto from here at the hotel. So this UI takes a little while to refresh. This was the West Coast deployment. And what I'm going to do is I'm going to say update, scale out, I don't know if you noticed in the blueprint, several of them looked like they were a little stack of cards. Let's just say from 2 to 4. So at this point, I have several nodes that are themselves clustered. The locators are clustered. I don't need to change the number of locators. The gateways are clustered. I don't need to change that. But the cache servers are clustered, and I want to change that. So I'm going to change that to 4. Generates a refined, a new execution plan, which basically spins up 2 brand new VMs, runs GemFire install, which is just laying the bits on the disk, runs the cache server install, which is the wrapper, our wrapper piece, and then starts it. Okay, and then when those are done, it's going to flow over and kick the update script. You can see the in caps update up here. The update script for the rebalancer. Now, you could write, I mean, whatever your runtimes are, you would call it, we call it rebalancer because that's a meaningful verb for GemFire. But you would call it whatever you're going to call it for something. If you're deploying balanced LDAP systems, or you've got Redis databases, or you're doing Mongo, or you've got your own app server clusters that need certain things to happen, and for the business objects that you have in them. Yes, sir.
Sorry,
No, please.
so like the cache server thing in that diagram, is that it actually spun a new VM just to run that Java process, and does it kill it afterwards?
We did instantiate a VM, and it does not quit afterwards. And here's why. At least VMware's hypervisor, a operating environment that's not doing anything will shrink down to a minuscule amount of memory and no CPU. So at that point, once the rebalancer, say, is not needed, it's really like a little LED on a light switch for the bathroom that's just glowing. Yes, the light switch isn't on. It just came on because the lights are off, but it's using very little resources to show so that you can find it at night, kind of a thing. It's that notion. So because we know that our underlying hypervisor is very efficient in that way, VMs are free. We just spin them up and leave them. Now, this is a 512 meg allocated one. It's very small. It doesn't use up, wouldn't even use much if it wasn't, if it actually had to do things. But in this case, we just signal it that we want it to do the update. And this will take a few minutes to spin up. What I did, I think I added 2 VMs. So the 2 VMs are spinning up in parallel. Why don't we, whoops. Oh, wait, this is, I think maybe actually they're done. Yeah, so I've got 2 servers. Right now they're queued up. As much as I feel that I'm very important to VMware and I should have my own private hardware, I actually have to share blade servers with lots of other people. So right now the job is queued up, so it doesn't actually take anywhere near as long as it seems to take, unless, if my colleagues would just not go to work today. But it will spin up, and then once the VMs are loaded, the guest OS images are loaded into the VMs, then the bits are installed. It's just a matter of seconds, frankly, to spin that up. Go back over here to the blueprint for a moment while that's running. So notice the ease with which it is to design clustered systems and dependencies and order them, right? You grab these little gray boxes that represent some OSs, you drop them on a canvas, you click one of these plus symbols to say, hey, I want it to be clustered as 2, 3, 4, whatever. You draw some dependency lines of how it's wired together, and automatically properties like IP addresses happen. We don't, more and more logic is just configured with the IP address. We're not actually baking in a machine name anymore. We're just doing URIs that are IP address / whatever. Those are what get dropped into the configurations for the install of things, how they're plumbed together in clouding environments. So these are IP addresses that don't necessarily have to be reached directly. The locator is you connect to the locator, that you want to be discoverable by your applications. But we would look at this pattern now to say, man, I've got a lot of applications that I want to get access to this database, and what's that going to look like for them? I want the clients to be able to reach those locators. Well, now with the metadata service, we can just say, look, the distributed ID that your data is going to be on is this. We've registered the metadata service into a well-known location, maybe a DNS name, metadata service, for GemFire. And then we would write, a little bit of launcher class into our client applications that would go discover the locators, and after that they're bound in and they go. They know their regions, or they would go ahead and the app might configure the region on its own startup. Makes things like A/B roles more tractable. I can start thinking in terms, maybe a little bit harder for data to migrate it to B, but for application logic clusters, if it's this easy to do the deployment, and I have a cloud, well, why not think in terms of a metadata service that would let me go ahead and stand up and flame test version B, and then as its final step of logic come in and be triggered and trigger a step that would say how really for the semantics of whatever logic, whatever servlets I've got deployed to those app servers, what does it mean to quiesce one and move to the other? Lots of times just simply waiting, telling your load balancer to stop sending load isn't quite the same quiescence. We'd like to say that we're state-free, but we're not always state-free. Here's a way to tie that in so that it's part of the deployment. Instead of having to upgrade and fix in place app servers, leverage the power of what the cloud gives me as a multi-tenant environment, spin up another one, get it all validated, and then as a last step on the validation logic all running and successfully, decommission the old one. Tear it down. Start the process of whatever quiesce means for the semantics of your business objects. There's many of these kinds of problems that we have to start getting ourselves trained to think about if we want the power of PaaS to truly come about. I know it's what Cloud Foundry can do today is very sexy. Every college computer science student probably is happy that they have such things to make their projects easier. But operationalizing that kind of thing, addressing all of the non-functional requirements in that kind of a runtime when I can't see and touch and actually enforce it, very nervous does it make as Yoda would say, very nervous does it make the ops guy, right? We're just about winding up. We're just about out of time, that is to say. And I wanted to obviously give you guys a chance to ask final questions. Thanks for sticking it out. And I think I have still a PowerPoint here somewhere to just kind of summarize this, net it out. I find I've been looking for a tool like Application Director for 10 years. It does a lot. It simplifies these kinds of deployments and makes them repeatable and non-breakable in ways that when I was writing scripts for TI mini computers in the 80s and other things in the 90s and still other things in the 2000s, it just simplifies things. I like the boilerplate. But there's still problems, big systems problems, that it does not yet solve. But with a little bit of thought about how to use something like Spring, how to get to the programming model where I'm not having to separate my coding model, my configuration is in Bash and my code is in Java and something else is in a mix of XML, maybe with good XML schema and other things with DTD, how can I get this normalized into an environment that it's much easier for me just to hand it off to other workers? And I like where we ended up with a bit of Java code that implements lifecycle properties using the hard work of the Spring guys to have created Spring Gemfire, so that I can now have something that's very natural to me in my development world context. I have a programming style that's very natural to me, Spring, and I can, on the fly, configure things, and I can get these properties of waiting and ordering things so that I have extremely predictable runtime deployments. And I get to leverage that multiple times per day in dev, maybe daily in QA. If I tie this into Jenkins with continuous integration, I can build up a perf environment and just build up other blueprints that just load it and say, I want to see what this does. I can start moving to swim lane deployment architectures in prod so that I can truly do A/B tests, like Netflix is very popular for having done. I get lots of these things that, because the overhead of deploying is gone. I mean, design it once, tune up the individual profiles, and just start blasting them out. So I liken where we are today with Application Director and frankly where we are with Cloud Foundry to, I think we're at PaaS minus minus. We're not at infrastructure as a service plus plus, we're at PaaS minus minus. That's, really what I told other customers I've gone into. I liken this to, it's the assembly language era and Java's coming. It won't take 20 years for that transition in the industry for PaaS by any stretch of the imagination. But we are really close to something that is very different for how we build product in the future. But we do have to go through these first steps of having to still do some things where you have all the control like you did in assembly and then C before you get to all the abstractions of object-oriented languages and then frameworks further abstracting this away. We better understand how all these wiring and all these non-functional considerations need to be met. And this is a great way to start encapsulating those concerns into little wrappers that go do work for us, but still tie it in so that ultimately the underlying thing that we're doing will just benefit as the tooling improves, because we just get to decommission wrappers that we've written. And with that, any final questions? All right. Thanks so much for your attention.